Okay, everybody. All right. Well, now that we've really added some power to our spreadsheet in the lecture video, this is going to save us a lot of time here, right? Um, let's start off with the simple, questions here on the first page, though, right? If we've got these three stars, Akanasi, Bada, and Seriero, all right. The first two stars have luminosities of one solar luminosity, so they're the same luminosity as the sun. This one only has a quarter of a solar luminosity, so it gives off a quarter of as much energy as the sun does per second. Right? This one is 10 light years away, then these are both 5 light years away. Okay, so which of these stars is actually brighter? Well, when you're talking about the actual brightness, right? When you're talking about how bright a star is actually, you're talking about how much light does it really give off. And that's where you're talking about luminosity. So what the question's asking is, which star has the highest luminosity? And you know, okay, is it Akanasi, Bada, or neither? And the answer is both, right? They're both. They both have the same luminosity. Right? Which star seems brighter? Well, the flux, if we want to get really rigorous with it, the flux is what? The flux is the luminosity divided by 4 pi times the distance squared. So, Akanasi and Bada have the same luminosity, so they're going to have the same luminosity, but they have different distances. So, which star seems brighter, right? When you talk about how bright a star appears or how bright a star seems, then you're talking about how much flux is that star shining down on the Earth with. Right? And the star that gives us the greatest flux is going to have the smallest distance, right? We want to divide by the smallest number here. If we divide by the smallest number here, we'll have the largest flux. So we can't change the 4 in the pi, but the star that has the shorter distance will give us the greater flux. Which one has the shorter distance? Bada does. Okay. We don't need to do the math. It's just asking us for relationships here, right? Essentially what we're saying is, if you've got two stars that are the same brightness, they're giving off the same amount of light, the star that's closer to us is going to look brighter. The star that's farther from us is going to look fainter. Sure. So, Bada has a greater flux. Bada has the greater flux because it's closer. And if I were writing this down to actually review later, I'd probably write this down with better handwriting, but, you know. Which star seems brighter? All right, Bada or Seriero or neither? Let's see. Bada gives us greater luminosity. Seriero gives us less luminosity. So Bada's giving off more light. Seriero is giving us less light, but their distances are the same. So which star is going to give us more flux? Well, if the distance is the same, then the bottom here, the denominator doesn't change, right? If the denominator is the same for both of these stars, then the star that gives us the greater flux will be the one that has the higher luminosity. In other words, you've got two stars that are the same distance away. The star that gives off more light is going to look brighter from here. So again, it's Bada. Right? Bada is going to seem brighter because it's going to be giving us more flux because it has a higher luminosity. And I'll let you write that down for yourself rather than make you watch me write this. Okay? No questions on the next page, right? Okay, good. Okay. So now we've got more stars to investigate, right? We've got these 6 stars. You measured their fluxes. You measured their parallaxes. What can we figure out? Well, if you have the parallax, you can figure out the distance. And if you have the flux and the parallax, then we can figure out the luminosity, right? But before we fill that out, these questions are saying, without doing any math, which star is brightest as seen from Earth? What's another way of measuring how bright a star appears from Earth? That's the flux. So without doing any math, just look at these stars. Which one has the greater flux? Well, they're all small numbers, right? Again, scientific notation makes life a whole lot easier, right? This one is the largest number, so Sirius must look brightest from Earth. It must, because it's giving us the greatest amount of flux. All right. Write your answer, explain your reasoning. Without doing any math, which star is closest to the Earth? Okay, well, if a star is closer to the Earth, is it going to have the greater parallax or the smaller parallax? The greater one, right? The greater the parallax, the closer the star must be to us. So which of the stars has the greater parallax? Looks like Sirius again. Yeah, okay, yep. Mm-hmm. That Sirius has the greatest parallax angle, so it must be closest to us. All right. Which star is the most luminous? Well, now we need to actually do the math. Okay, so pull out our handy-dandy spreadsheet to do this for us. And you say, oh, I already got Sirius set up here, right? Sirius has not 0.03, 0.379. It has a parallax angle of 0.379 arc seconds, and it has a flux of, and now here you can use the E notation in your spreadsheet, right? 1e minus 7. Remember the E stands for times 10 to the power of whatever you put after, right? So if you want to put in a flux of 1 times 10 to the negative 7, you just put in 1e minus 7. There we go. This parallax, the spreadsheet is telling me the parallax angle in scientific notation, right? So it's still the same number, it's just in scientific notation, and I don't want that. That's going to look annoying. So I'm going to change that. Go into Format Cells, change that to a decimal instead of scientific notation, and okay, now that looks the way it looks on my spreadsheet. So that'll be more appealing. Okay, so Sirius has now again, here's a case where you're not going to write all these numbers down, right? You're not going to write all of these decimal places down because we don't need, or our measurements can't justify all of these decimal places, right? Both for the flux and for the parallax, we've got three significant digits, right? For all of these, right? For the fluxes and all of the parallaxes, we have 3 significant digits. Well, no, I guess actually we don't, right? This one is 2 significant digits and that one is 2. So I guess we'll have to round differently there. Okay. But for Sirius, we're going to round to 3 significant digits. So Sirius has a distance of 2.64 parsecs, or 8.60 light years, and has a luminosity of 21.7 solar luminosities. Sirius is 21 times brighter than the sun. It gives off 21 times the amount of light that the sun does every second. And you'd think, well, yeah, I mean, it's the brightest star in the sky, right? It's the brightest star in the night. And this is true, right? Sirius is the brightest star in the night sky. It's the star that gives us the greatest flux in the whole night sky. So it makes sense that it's 21 times brighter than the sun, right? It's got to be super duper bright, right? Well, let's look at these other 5 stars. Right? Arcturus has a parallax of 0.089. arcseconds and a flux of 2.79 e minus 8. Okay, so Arcturus has a distance of 11.2 parsecs, or 36.6 light years, and it has a luminosity of 109.99. Well, I guess I have to round that up to 110, don't I? Okay. And I'll just leave it as 110 because I've got two significant digits here, so I'll just leave that as two significant digits right there. All right, that works out well. How about Vega? All right, Vega has a parallax angle of 0.129 and a flux of 2.59 e minus 8. So Vega is only 7 parsecs away, or 25 light years, and has a luminosity of 48.6 solar luminosities. Okay, well, all of a sudden, our assumption at the beginning that, like, wow, Sirius must be super duper bright for it to look so bright in our night sky. All of a sudden, these other stars are starting to show it up. All right, how about Betelgeuse? 0.0076 arcseconds of parallax and a flux of 1.75 e minus 8 watts per square meter. Betelgeuse is 131 parsecs away, or 429 light years away. And it has a luminosity of 9,460 light years, if we round to 3 significant digits. I guess it's a 2, right? We should probably round to 2 significant digits. Oh well, yeah, it's fine. Altair, 0.194 arcseconds of parallax, 1.32 e minus 8. Ooh. Did that wrong. All right. Okay. Well, that one, Altair, is only 5 parsecs away, or 16 light years, so that's a lot closer to us. And that's only 10 times brighter, 11 times brighter than the sun. All right, and last but not least, Fomalhaut is almost the same distance as Altair. Well, a little bit different, right? 7 parsecs, 25. Here, I'll move this out of the way so that you can, well, you know what I'm writing down. 25 light years, or 16 solar luminosities. Okay, so all of these stars. Now, these six stars are the 6 brightest stars in the night sky. We picked these on purpose, right? These are the 6 brightest stars in terms of flux in our night sky as seen from Earth. Right? Which one has the highest luminosity? Question number 3. Which star is most luminous? Which star has the highest luminosity? Well, it's Betelgeuse by a long shot. Right? Why is Sirius is the brightest star in the sky the same as the most luminous? What's the brightest star in the sky? Sirius. Well, in the night sky, Sirius. Right? Sirius shines on Earth with more light than Betelgeuse does. Even though Betelgeuse is giving off much more light than Sirius is in total, right? Betelgeuse's luminosity is much, much, much more than Sirius's is. So why does Sirius look brighter from here on Earth? Well, it's a lot closer. right? Sirius is only 2.6 parsecs away, whereas Betelgeuse is 130 parsecs away. So because Betelgeuse is still the fourth brightest star in the night sky, even though it's much farther away than these other stars. How can it look this bright from a much, much greater distance? Because it's that much brighter. Right? Sirius is the brightest star in the night sky, not because it's giving off a hellacious amount of luminosity. It's just closer to us. Right? It's one of the closer, it's only 2 parsecs away. Right? But this is why I say, right? Now we're getting somewhere, right? Now we know by these two little measurements, right? Measure the parallax, measure the flux, and now we know two real things about these stars. We know how far away they are, and we know what their luminosities are. And now we're getting to know something real and physical about the stars. We know how much energy they're pouring out every second. And then we can start asking the next more interesting question: how can this be? How does Betelgeuse, how do these stars give off 10 times, 100 times, 20 times the brightness of the sun, and Betelgeuse gives off a whopping 9,000 times? There's something really interesting going on there, right? Some stars are much brighter than the sun. And some stars are much dimmer than the sun. We just can't see them very well here in the night sky. They don't look that much brighter. They don't look that bright from here on Earth. And now that we've figured out a way to tell some real physical property about that star, luminosity, then we can start digging deeper and asking why. And that's where we're going to get to over the next few lectures. So, I hope this is making sense. And as always, if you're stuck and not sure why these are the right answers, then post a question to the discussion or come into office hours. And have a good day.